we are going to look at a slice of pie. Many students begin the study of circles in geometry without any understanding of the number pi and its mathematical power. During the lesson, I will conduct some experiment to determine the ratio between the diameter and the circumference of various circular objects. From the experiments, you will be able to recognize a constant ratio between the circumference and the diameter of circles. From this, we will then be able to approximate the value of pi. Let's first examine the circle. What is a circle? At the most basic level, a circle can be defined as a closed two-dimensional curved geometric shape. Let's take a closer look at a circle and its properties. Our focus will be on the circumference, diameter, and radius. Expanding on the original definition, a circle can be defined as a closed two-dimensional curved geometric shape in which the set of all points on the circumference are equidistant from a given point called center. What is the circumference? The circumference is the perimeter, the distance around the circle. The diameter. The diameter is a line segment which passes through the center and touches 2 points on the circumference. The radius. The radius is a line segment which extends from the center and touches a point on the circumference. So, how do you find the area of a circle? First of all, the area of any shape is the total space of that shape which is enclosed by a border. Therefore, the area of a circle is the total space enclosed by its border. The formula for the area of a circle is pi r squared, where r is the radius, and in text or math problems, we usually see pi as 3.14 or 22 divided by 7. But what is pi, and how is its value of 3.14 determined? I'll investigate this now. First, I am going to measure the circumference and diameter of some circular objects. I have a roll of masking tape, a clock, and a bucket. Then we will determine the ratio of the circumference to the diameter. I'll be using 2 different units of measure, centimeters and inches. So first, let's measure our tape. So our tape has a circumference of 33 centimeters and a diameter of 10.5 centimeters. Second, let's measure our clock in inches. So the circumference of our clock is 37.7 inches and a diameter of 12 inches. Lastly, we'll measure the circumference of the bucket. So our bucket has a circumference of 77 centimeters and a diameter of 24.5 centimeters. By inserting the measurement obtained from the objects into the table, let's determine the ratio of the circumference to the diameter. Our masking tape had a circumference of 33 centimeters and a diameter of 10.5. We will now divide this to get the ratio of the circumference and the diameter. And dividing this should give you 3.142 and so on. Secondly, let's insert the measurements for our clock. So our clock had a circumference of 37.7 inches and a diameter of 12 inches. So to show the ratio between the circumference and the diameter, again we will divide. And dividing gives us 3.1416. Lastly, let's get our measurements for our bucket. Our bucket had a circumference of 77 centimeters and a diameter of 24.5 centimeters. And dividing this gives us 3.142 and so on. You should have recognized by now that despite the size of the unit of measure, the approximate value of pi remains constant. Earlier, I looked at the formula of the area of the circle. Before the formula is used, look at this animated representation of how the area is calculated. If we cut our circle into small enough sectors, we can form a rectangle. Remember, the area of a rectangle is length times the width. When our sectors form the rectangle, the width is the measure of the radius. The lengths, however, are represented by the circumference of our circle. Dividing our circumference by 2 will give us pi r. The length is pi r. So if we multiply the length times the width, we will get pi r times r, which gives us the pi r squared. I will now apply the formula using pi r squared to calculate the area of a circle with a diameter of 17 centimeters. So to calculate the area of the circle with 17 centimeters as our diameter, first we need to find the radius. Remember, the area of the circle is equals to pi r squared. To find the radius for our circle, we first have to divide the diameter of 17 centimeters by 2, giving us a radius of 8.5 centimeters. Now we know our radius is 8.5 centimeters. We can insert that into our formula. So area is equals to 3.14 multiplied by 8.5 squared, giving us an area of 226.9 centimeters squared. So today we looked at the relationship between the diameter and the circumference and how pi came about. We also calculated the area of the circle. So until next time, have a slice of pie.